So in section 5.2, we are looking at sigma notations and limits of finite sums. So first things first, sigma notation. So sigma notation is introducing a more convenient way to represent sums of large terms of numbers, or large sums of terms. So what is sigma notation? So again, we're thinking about a large sum of numbers. So for example, let's say we have x sub 1 plus x sub 2, and we keep going la 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 all the way up to x sub n. So you could have n terms. Imagine where n is a very large number. So how do we write this in a more compact form? So we use our sigma, and this is from k is 1 to n of x sub k. So what does all of this mean? So this is where, we'll give ourselves a little more room. So this is where this sharp E is our sigma, right? The Greek letter S. So this is the summation symbol. Now K is the index of summation. And let's make a couple notes here about the index of summation. So with the index of summation, notice here that it's starting at 1. So we have what we call the lower limit, where k is equal to 1. This is your lower limit, or your lower bound. And then notice as k values go all the way up to where k is n. So this is your upper limit, or your upper bound. And this doesn't have to start at 1. We could use any integer value here. 1 is typically used as a starting point, but it could be any integer. And then the last thing I want to note is x sub k. And x sub k is the general formula for the kth term. So in this section, we're going to further explore how to expand the sum in its sigma notation, or how to rewrite a sum into its compact sigma notation form. So let's explore.